Hello, everyone. My name is Harideep Chivri. I'm a senior solution architect at Robin.io. And today's topic, I'm going to talk about demystifying the complexity of cloud-native 5G network functions deployment using Robin CNP. Robin CNP stands for Robin Cloud Native Platform. Let's get started. So before jumping to how Robin solves the problem for the 5G cloud native deployment, let's talk about what are the key challenges that operators are currently facing for deployment of their 5G network functions. So some of the key requirements when operators deploy their telco data centers are their managing their network function, whether in a cloud native world, to achieve things like low latency and high throughput for the 5G applications, as well as highly scalable and achieve a very good performance at the edge, as well as at the core for their 5G solution. So in order to achieve that, they need to place the workloads in such a way that whether it's on edge, far edge for radio sites, since everything is getting containerized, moving into cloud native world, whether it's a RAN, CU, DU workloads, or if you take a core 5G standalone core as well. They all need these kind of custom fine tuning for deployment of application on a bare metal server or in a cloud environment in order to cater the SLAs that 5G service requires. And then all of these 5G network function typically requires multiple network interfaces, and also they should be redundant to failure, port failure. So there should be bonding, NIC bonding, and also the IP address assigned for these network functions should be persistent. And sometimes you need static IP address for the application in order for the other network functions or other elements in the network to communicate with them. There are requirements such as there need to have multiple gateway support, one for management, one for data path. And there also need to have dual stack support. That means IPv4 and IPv6, whereas in one interface runs on v4, v6, or it could be same interface on the cloud native world has v4 and v6 address. And there would be scenarios where customer would deploy v6 IP pool as well as v4 IP pool. So in that case, there is a need for dual stack support in a cloud native deployment as well. And there are scenarios where operators will have some vendor application still in VNF format. It comes in VM format, not in containerized yet. So the operators need to build a separate cluster or cloud platform to run the VMs such as OpenStack or VMware cluster, which would be very hard for operators to manage multiple clusters for different vendors. And there will be a path for them to move into containerization. So these are some of the main key challenges when deploying and how they can be achieved without a lot of manual effort. So today, in order to do the isolation of resources as well as configuring the host to achieve the CPU and memory, get the enough resources and isolating all of that for the application as well as deploying into same NUMA node are some of the key challenges and to achieve a bare metal performance. So let's take a look at how we solve that, right? Using Robin CNP platform. Before we go into there, let's take a look at Robin CNP architecture. So Robin CNP cloud native platform is a carrier grade Kubernetes platform, is built on top of Kubernetes, which is open source Kubernetes. And we have enhanced that Kubernetes into a carrier grade using enhancement on networking, storage, and application placement or scheduling. Robin CNP can be deployed anywhere, whether it's bare metal, VM, or any public cloud. And we have one-click deployment script that can go and deploy your entire cluster using one single script, which can package all the things that we bring in with the solution and can be deployed anywhere using the same script. So first of all, on top of the open source vanilla Kubernetes, we introduced carrier grade networking. When I say carrier grade networking, it includes all the open source CNIs that are available or that are handpicked, required for operators to run their vendor applications. These are most commonly used, such as Calico, OVS, MAC VLAN, SRIOV, and DPDK support, overlay networking, underlay networking support, persistent static IP, persistent and static IPs, dual stack support. All those things are built in and integrated with the solution so that the operators just need to bring their applications, and we will make sure that all the requirements are met on the platform and they just deploy the application. Same way, there is a Robin application aware storage, which is a storage solution for cloud native, which would take care of extracting or understanding the requirements of the application and make sure that your storage disks are programmed accordingly. So whenever Kubernetes or your application requests for a volume, we will make sure it is rightly placed for redundancy, such as making sure the volume copies are available on all the disks, across, highly available across different hosts. And also you can take application snapshot, clones, backups, and restore into same cluster or different cluster scenarios, such as migration, taking a backup of application with the same underlying information that we store will be retained on the new cluster. Or if you restore into the same cluster, we'll make sure same resources are met. So it is an infrastructure aware, application aware storage solution that would basically take care of all the storage needs for a cloud native deployment. Additionally, we also have advanced scheduler, such as NUMA aware CPU pinning, huge pages, affinity, anti-affinity based placement of applications in Kubernetes world. So that you can place your application into specific host or specific node, and as well as specific rack and things like that. So that advanced placing, as well as within a host, how do you place different applications so that you can utilize maximum amount of resources from a server and able to deploy the application. Also, we have observability and monitoring built in using open source Prometheus and Grafana. And the users would be able to deploy the application either using Robin bundle, Helm charts, or kubectl commands. We also have full API integration for end-to-end automation for lifecycle management of the application, including deploy, scale, upgrade, and snapshot. So all the operation that would do using CLI or UI would be able to perform using API as well. Now, let's take a look at what are the key 5G use cases that we solve. So Robin currently solves the problems for the RAN, cloud native RAN, as well as MEC and core, and also any application that runs as CNF, VNF in the telco environment are the 4 use cases that we solve. So for the RAN, we make sure that on top of basic Kubernetes or vanilla Kubernetes, we make sure advanced scheduling and networking storage and networking requirements for application is fully automated. So the application owners just need to specify what they need. We will make sure those are achieved and available on the underlying host using advanced automation placement rules, and also making bare metal performance with a low latency and high throughput achieved on the hardwares where the RAN, CU, DU workloads are deployed. Same way goes with the MEC application, mobile edge computing. Those can be deployed along with a RAN, CU, or UPF, or an enterprise, or in an edge application that needs to go in the edge data center. So we'll make sure that those are again satisfied. Again, that highly scalable 5G core that needs to run in central data center is also taken care with the storage and network use cases that are required for those applications. And at the same time, we'll make sure that if the application vendor has a CNF container network function or VNF virtual network function that needs to run on the same platform at the same time, we can manage that on Robin and also manage the life cycle of the application using Robin bundle or Helm chart. So we can, the operators and vendors can bring in their application packaging in their model, and we will be able to manage it on Robin platform. So we talked about carrier grade networking. How do we achieve a carrier grade networking stack using open source CNIs? So here is a high level logical picture of how Robin CNP uses different components in open source Kubernetes. So on an abstraction layer, Robin has Robin IPAM, IP address manager, which is our IP pool. The users and the administrators can create different IP pools on different tenants, and that can map to different tenants once you create it. So one IP pool can have an IP address, subnet range and mask and gateway related to that specific network. And that network can be mapped to a specific driver such as Calico, OVS, MacVLAN, SRIOV, or if you're deploying in public cloud, AWS CNI or Azure CNI. And for SRIOV, there could be additional drivers like for kernel-based driver, IAVF driver, or IGBUIO driver, or VFI or PCI driver for DPDK applications. You can also specify additional settings on the IP pool, such as DNS routes, NIC tags, and tenant. So once you create an IP pool, when you're ready to deploy the application, you can just specify the IP pool name for the application, and you can have more than one IP pool assigned for the application, whether it's a CNF or VNF. And in order to have multiple IP address assigned for a container or a pod, we will of course use Multus CNI. So Multus CNI will be invoked in the stack, and depends on what kind of networking you need for your first interface, whether it's a Calico, and second interface goes through OVS, and we will create an OVS bridge, and OVS CNI will be invoked accordingly. Then depends on what other interfaces, such as if you need for control plane MacVLAN and for data plane SRIOV interface, we would invoke those CNIs as needed for the interfaces as defined. You could have the improved packet per processing using some open source libraries such as DPDK or VPP, which would improve the application performance using SRIOV interfaces. So we would support those libraries and the integration with those on the Kubernetes platform. And you could directly talk to the NIC cards, such as Intel Mellanox cards, the smart NICs that comes in which can do high throughput, low latency applications. Whether it's for RAN or core applications, would be able to satisfy that. So looking at this picture on a telco data center, so end-to-end stack can be achieved connecting to the top of rack switch all the way to the IP address management of your application. That comes as a carrier grade networking stack that we built on top of open source Kubernetes. Now that we have talked about the networking part, now how does you place the application into a host, right? So as you know, the Kubernetes comes with the master, controller, as well as compute worker nodes, right? So same way, the Robin has a construct of master compute and storage nodes. And when you place your edge workloads into a worker node, typically there would be the servers or the hardware servers has multiple NUMA nodes, NUMA 0, NUMA 1, or could be more. So the key condition for achieving the best performance on these edge applications for these x86 servers by having resources from the same NUMA node. If you are crossing the NUMA boundaries and consuming a resource from another NUMA node, then your performance would be degraded up to some level. So in order to make sure that the performance is met, we'll make sure that the resources such as CPU, memory, huge pages, SRIO Unix, GPUs, or FPGA cards are assigned from the same NUMA. So in order to do that, Robin automatically takes care of scheduling your application into same NUMA node based on the input from your application packaging. Such as your Robin bundle, you can say, I want reserved CPU, or in Helm chart, I want a guaranteed port. So then Robin would make sure that, I mean, you look for all the available hosts, and wherever there is a single NUMA node with all the resources available, we'll take care of that. Instead of statically going, finding out and placing the workload manually there, the Robin Planner would be able to take care of that. And we have tight integration with Kubernetes Topology Manager to achieve NUMA-aware placement for guaranteed or shared CPU pods. Also, we have integrated Robin IP pools that I've talked about earlier into Helm chart, so that you would be able to specify those IP pools in Helm chart annotations, so that you don't have to define any statical entries of PCI address or huge pages into the Helm chart. It would be automatically taken care as part of the IP pool. And then also running VNF on CNP with KVM hypervisor is also possible, that you create a Robin bundle and specify the engine as KVM. Then the application is deployed as a VM and would be able to, using underlying libvirt and KVM libraries, to onboard the application. But the management would be still look like a Kubernetes control plane, where you would see a pod running and you would be able to do all the lifecycle management, just like the Kubernetes manage and Robin application management. Also, we can do dual stack support for the applications, like I already mentioned in the previous slide. Let me talk about a little bit about what is Robin application bundle. Robin application bundle is a packaging of application into deploying into cloud native platform. And it's similar to Helm chart, but it has much simplified and more intuitive operations that you can perform on the application. The first thing is the manifest YAML file, which is a blueprint of the application, where you can describe the compute, storage, networking, and requirement. Additionally, you can have multiple other configurations, such as whether snapshot enable, you want certain app hooks to be run, and the certain like affinity, anti-affinity rules that can be placed in the manifest YAML file itself. So it's a single file with the entire definition of application, compared to having it across multiple files. Then you can have an icons directory. Then there could be scripts directory, where you could have certain tasks to be executed, pre-execution and post-execution. After deployment, you want to do certain checks, or before taking snapshot, you want to do something, or after taking snapshot, you want to perform certain task on the application. Those are can be written under scripts directory. And finally, you have a source directory, where you can have additional Docker image related parameters specified, or you can additional files need to be pulled for the applications. That's how you package a Robin bundle, and it can be uploaded easily into Robin CNP, and you'll be able to deploy application like an app store experience. Same way, we can also support the open source Helm chart, where you can define your application into Helm chart, and you can bring those Helm chart as it is and run on Robin. Additionally, you can integrate Robin IP pools and storage, such as PV, PVCs, WX volumes. All those things can be integrated, and Robin storage would and networking stack would be integrated to the Helm chart with some simple annotations. Okay, now we talked about different scenarios, how we solve, how we reduce the complexity of deploying that. Let's take a live example case study of one of the production customers that have successfully deployed and running in production using Robin CNP. So Rakuten Mobile Network, they have built their next generation 5G fully containerized, running on top of Robin CNP. So looking at this diagram, they have three types of data centers: central DC, regional or edge DC, and far edge DC. On the central DC, all the core applications such as AMF, SMF, RIC, EMS, all those are core applications are run. Edge, where all the UPF, CU, and some of the RAN components and some MEC application would run. And the far edge is very close to the radio towers or RU, where the DU instance of the radio runs. Robin also has another product called MDCAP, multi-data center automation platform, which would do the end-to-end automation for all these workloads and also the cluster management across all of that. And then depends on the size and location of the cluster, we can scale from with a single server cluster to 100 to 200 server cluster, depends on what customer would like to. So if in this example, some of the DUs are very smaller clusters, and of the edge clusters are minimal number of servers, and when the core clusters are with hundreds of servers in there. This is one example of the clusters, and also with the automation and service orchestration lifecycle management, MDCAP would manage that, but individual CNP cluster will be able to monitor and manage the cluster with open source Prometheus and Grafana for the for health and monitoring of the cluster for the operations purpose as well. So just to wrap up the session, why customers choose Robin, right? So these are the main reason why customers choose Robin. One is deploy of stateful applications on Kubernetes, deployment of 5G RAN and at scale for operators. So the stateful applications need a lot of awareness of the infrastructure, which is taken care automatically on Robin platform. And deployment of 5G RAN and core needs a lot of scaling and also performance tuning on across different sites. So this is again achieved on Robin CNP. Also deploy and manage applications at edge, MEC applications or enterprise edge applications. Also, we use the same platform to run containers and VMs, whether it's even if it's a Kubernetes, we can run both container network function and virtual network function. You can use the same platform to run hybrid and multi-cloud. So if you have some resources running at on-prem and some on public cloud, you can run Robin anywhere to manage that. Or if you have a multi-cloud environment, can be achieved using Robin platform. Robin also automate day two operations, the automation at hyperscale, and also day two configuration management, monitoring, lifecycle management of the application and the clusters as well. So with this side, we simplify the operations and management of 5G applications at scale, and also this demystifies the complexity of how the myth around how complex the 5G network function. When it comes to Robin CNP, it shows how we simplify all that for the end users, and they don't need to worry about the underlying complexity, the simplified automation and user interface, as well as the management of the application makes it the life easy for the operators to deploy the application. All right, thanks for watching. Thank you.